Welcome to our channel. Have you ever pondered how hurricanes, these massive storms that cause widespread destruction, actually form? Welcome to the captivating world of meteorology, where we unravel the mysteries of nature's most powerful storms. Hurricanes, cyclones, typhoons, different names, yet they all refer to the same phenomenon. These are not mere whims of Mother Nature, but complex atmospheric events that follow a precise set of rules. A hurricane's birth begins over the warm tropical oceans, where air above the water's surface heats up and rises, creating an area of low pressure below. This sets in motion a domino effect of meteorological events, with cooler air rushing in to fill the vacuum, only to be heated and rise in turn. As this cycle repeats, winds spiral and gain momentum, giving birth to a hurricane. But remember, each hurricane is unique, and the exact conditions required for their formation remain a topic of ongoing research. So the birth of a hurricane is not as simple as it seems, right? Now let's delve into the science behind these colossal storms. A hurricane is not born overnight. It's a product of a perfect storm, so to speak, of several key conditions. Primary among these is warm ocean water. You see, hurricanes are tropical beasts. They thrive in waters that are 26 degrees Celsius or warmer. This warm water is the fuel that powers the hurricane's engine. Next up is moist air. Picture this. Warm ocean water evaporates, rising up into the atmosphere. This moist air is a crucial ingredient in the hurricane recipe. It's like the yeast in your bread, whipping up the storm. Wind patterns also play a crucial role. For a hurricane to form, the wind must be just right. It must allow the storm to spin without tearing it apart. This is why hurricanes tend to form in certain regions of the world where the wind patterns are ideal. Now, let's talk about the magic of evaporation and condensation. As the warm ocean water evaporates, it rises and cools, condensing to form clouds. This process releases heat, which warms the surrounding air, making it lighter. This lighter air then rises, and the cycle continues, creating a self-sustaining heat engine. This is the heart of a hurricane, its engine room, if you will. From here, our hurricane goes through several stages of development. It begins as a mere tropical disturbance, a cluster of thunderstorms over the warm ocean. If conditions are right, this disturbance can grow into a tropical depression, then a tropical storm. And finally, if it reaches sustained winds of at least 74 miles per hour, we have a full-blown hurricane. The formation of a hurricane is, in essence, a dance of nature. The warm ocean water, the moist air, the wind patterns, the evaporation and condensation, all coming together in a ballet of atmospheric conditions. It's a testament to the awesome power and beauty of nature, even when it's at its most destructive. As we've seen, the formation of a hurricane is a fascinating interplay of various natural conditions and processes. However, despite this understanding, there is still controversy surrounding the formation of hurricanes. The scientific community is not completely in agreement about certain aspects of how these powerful storms come into being. Some theories suggest that warmer ocean temperatures play a key role, while others point to variations in atmospheric pressure. The exact interplay of these elements and others continues to be a subject of ongoing research and debate. One of the most pressing issues is the potential impact of climate change on hurricane formation and intensity. There's growing concern that rising global temperatures could be creating conditions that are more conducive to the formation of stronger, more damaging hurricanes. Yet the relationship between climate change and hurricane activity is complex and not fully understood, leading to different opinions among scientists. Beyond formation, predicting the path and strength of hurricanes presents another significant challenge. Despite advancements in technology and meteorology, accurately forecasting a hurricane's trajectory and intensity days in advance is still a tall order. Unforeseen changes in weather patterns can alter a storm's course and strength in a matter of hours, leaving forecasters and residents scrambling to respond. Indeed, while we've come a long way in understanding these powerful storms, there's still much to learn. Now, as we shift our focus from the formation and prediction of hurricanes, let's discuss the impact of these powerful storms. Their influence is as wide-ranging as it is devastating, affecting not only human life and infrastructure, but also ecological systems and economies. First and foremost, the human cost of hurricanes is heartbreaking. These storms have claimed countless lives over the years, and their destructive power can leave communities in ruins. Buildings, roads, and other infrastructure are often torn apart, leaving areas uninhabitable and people displaced. But the impact of hurricanes doesn't stop at the human level. The ecological consequences of these storms are significant and far-reaching. Hurricanes can drastically alter landscapes, disturbing wildlife habitats and disrupting ecological balance. They can cause saltwater intrusion into freshwater ecosystems, leading to a loss of biodiversity. Moreover, the heavy rains and flooding related to hurricanes often result in extensive soil erosion and loss of vegetation, which can take years to recover. Finally, let's touch on the economic toll of hurricanes. The damage caused by these storms often runs into billions of dollars, burdening economies with the cost of recovery and reconstruction. Beyond the immediate damage, hurricanes can also have long-lasting effects on local economies, especially in regions heavily dependent on tourism or agriculture. Indeed, the impact of hurricanes extends far beyond the storm itself, affecting communities and ecosystems long after the winds have died down. This underscores the importance of continued research and improved forecasting to better prepare for and mitigate the devastating effects of these formidable storms. In conclusion, the formation of hurricanes is a complex and intriguing process, one that continues to captivate scientists and the public alike. We've dissected the science behind these formidable storms, from the warm ocean waters that fuel them to the atmospheric conditions that guide their path. We've also delved into the controversies surrounding their formation, particularly the role of climate change. So next time a hurricane makes the headlines, remember the intricate science and ongoing debate behind these mighty storms. Thanks for watching.